So why Golang is a lightweight language means how runs process runs fast. Do you have any idea?
It directly converts into machine code.
Okay.
It avoid dependency checking, so compilation is faster.
Other than that, what about the processes?
Routines.
Okay. So in today's lecture, we'll be covering a concurrency part in Golang. So the contents are today we'll cover Go routines, wait groups, channels, select statement, and sync and mutex. So when do you say concurrency? There are two terms, right? Concurrency and parallelism. So how do you differ these two terms? What is concurrency and how does it differ from parallelism?
In parallelism, tasks are parallelly performing, even though they are separate, but they are parallelly executing. In concurrency, tasks are separate and they are executing when one task is done. When machine is free, another task can go. That is not required. They should be all running simultaneously.
Okay. So rightly mentioned by him, concurrency is a process means we start the process at the same time, but they do not perform the task similar task at the same time. So let's consider one example. I'm doing a jogging and my shoelaces are untied, so I cannot jog while tying my shoelaces, right? I have to either jog or tie my shoelaces. So this is a concurrent process. I want to jog also and I want to tie up my shoelaces also. So when I jog, I stop, I tie my shoelaces and start the jogging again. So these are the process. These are running concurrently. While parallelism means I am doing coding, right? I am doing coding while listening and music. These are two parallel processes. I can do coding while I am listening music. Two can go hand in hand. There is one process has not to wait for the another process. So yeah, concurrency is the concept of executing two or more tasks at the same time. So that is the example I have given. A person trying to when a person is trying to multitask, like you are watching a TV while doing coding, so you cannot perform exactly the same task. Means watching TV and coding. So you will be continuously switching between these tasks. So this switching is known as the concurrency. Like two tasks are going on continuously, but our processes is switching between these two tasks. And how this concurrency is different from parallelism, right? So parallelism is when tasks literally run at the same time. Uh, it sounds like similar to the concurrency. It starts at the same time, it executes at the same time, and it ends at the same time in a particular order. So let's take the example. So let's consider there are two tasks. We have two tasks, task A and task B. So there are various processes of execution. The first one is a sequential execution, second is a concurrent execution, and third one is a parallel execution. So what happens in a sequential execution is that process A starts at time t, right? So it continues to start, and when it ends, then another process starts. So this is a sequential execution. No two processes has overlapping execution, right? Whenever one process is done, then only second process starts. Now the second is concurrent execution. So see that process A has started in concurrent execution. It has completed some part of execution, then it halted. The processor has switched context to the process B. Now the process B has executed. Again, there is a context switch in between the two processes. So this is a concurrent execution. So this can be performed in single thread or single processor. Single processor handles both execution of the both the tasks. While if you consider the parallel execution, let's consider as time. This is a time graph, horizontal. There are two processes A and B. Both start at the same time. Both are running in hand, right? So task processor one is executing process A, and processor B is executing process B. So these process start at the same time, execute at the same time. There is no context switching. So this is known as the parallel execution. So the difference is clear between what is concurrent and what is parallel.
Yes.
Okay. So in Golang we have concurrent execution. So like we can achieve concurrency in Golang using concurrent execution, but does anyone know what do you use for concurrent execution in Golang? Right. So in Golang we use concurrency. Concurrency can be achieved in Go with the help of Go routines. So what are Go routines, right? What do you understand by Go routines?
Go routines are like similar to mutex and locks in CPP. And in Go routines and using Go routines and channel will basically say that share the data, not the memory actually. Doing the implementation.
Like in Go routines, we tells them that sharing of memory or data should be done through communication. If I'm accessing some values, no other process or anything should be able to access the same value.
Okay. So yeah, this is how Go routine works. But Go routines, similar way we saw this concurrent task. So let's consider these two tasks as a function. So Go routines works in a similar way. So Go routines are functions or Go routines are functions or methods that run concurrently with other functions or methods. So if you compare this as a function A and function B, these two processes are running concurrently, right? So these are the actually Go routines. One Go routine is executing task A, and another Go routine is executing task B. So, but what is the difference between? We also have threads in Java, right? Threads in Java also do the same thing, executing tasks parallelly. So, why Golang is faster than Java?
Actually, the Java threads are managed by OS of the machine,
Hmm.
and Go routine threads are managed by the Go runtime.
Yeah.
Like the management of thread and sources for the running of that code is managed by Go compiler only.
Mhm.
And in Java, we have to manage manually, or the machine has to manage manually while the program is running.
Yeah, right. So Golangs are very lightweight as compared to the threads. It only takes some kilobytes of memory as compared to the threads. So cost of creating a Go routine is tiny when compared to the thread. So what advantage does Go routine have over thread? So this is a theoretical part. I'll go faster. So Go routines are extremely cheap when compared to threads. They are only a few kilobytes in stack size. Also, there might be only one thread in a program, while there might be thousands Go routine. Also, a Go. So we consider that there are two concurrent tasks, task A and task B. These two tasks are independent of each other. So if you want to communicate between these two tasks, so how do we can we achieve this? Yeah, right. So coroutines communicate using channels. Channels can be thought. Let's consider we have one pipe. We have to pass data from part A to the means from start end to the end end. So this is a pass through. We have to pass data through a pipe. Let's consider this pipe as a channel. Channel works in a similar fashion in Golang. Okay. So we'll cover channels in more deep in next slides. So now we have understood what Go routines are, right? So, but how to use these Go routines in our function or in our code? So, how do we call normal functions? We just declare a function A. We define that function, and whenever we have to call that function, we just call that function as A. But this causes a sequential execution of that function. But if I have two functions, function A and function B, I want to call this function concurrently. I will need to use a Go routine. So I'll call this function simply using a keyword Go. So I'll call this function as Go A and Go B. So this will call this function as a Go routine. This function, the compiler will not wait for a function to return first. This will start execution of both the functions concurrently. So the syntax is Go and function name. Yeah. So prefix the function or method call with the keyword Go, and you will have a new Go routine running concurrent. We'll see this with one example, with simple example. Okay. So I have a main function here. As we have taken in similar session, I have a for loop which runs 10 times. I have one anonymous function here which accepts one parameter I as an integer. It simply prints that parameter whatever it has input, and I will just call that anonymous function here. When this for loop ends, I have written at line number 16, I have made my code to sleep for 2 seconds, and at line number 18, I have just printed the hello world. So can someone guess what will this output?
The printing will be random,
Okay.
I guess, and then we'll wait for 2 seconds and then print hello world.
Yeah, right. So whenever I call this Go routine, let's see line by line execution. Our control is at line number 10. It's a simple for loop which will it will iterate for 10 times. There is a Go routine. There is a function called in a Go routine which prints simple value of I. So immediately, whenever the function is called 10 times, 10 simultaneous Go routines are spawned, irrespective of another Go routine. So function does not wait to run for loop for 10 times and print the value. So the execution immediately comes at line number 16. it doesn't know if we have printed at line number 12 or not. So immediately execution come at line number 16. I waited for, I halted my execution for 2 seconds with the help of time.sleep. Time is an internal standard Go package, and it provides a method called sleep. So we can provide any times in seconds, minutes, or hours, anything. So I halted my program for 2 seconds, and then I printed the hello. So let's check the result. Yeah, program halted for 2 seconds and it printed hello world. Okay. So have you observed the output? If I have not used the go keyword, it should be right to 0, 1, 2, 3, 4. It should be a sequential execution, right? But as this is a go routine, these 10 go routines are spawned irrespective of each other. So this is an random. We cannot determine which go routine will execute first and which go routine will execute last. So uh, if I run this program again, so will the output will be the similar one? No. Yeah. So every time when I run a go routine, the output will be different one. Okay. So the another property of this go routine is, does anyone know what is the significance of line number 16? Why do we have explicitly mentioned that our program needs to sleep for 2 seconds? Any rough idea?
To let the program wait for all the go routines to execute.
Oh, yeah, right. So in Golang, the main go routine is the main actual parent go routine. Whenever the main go routine exits, all the child go routines exits itself. So this go routine does not get times to execute themselves, and when the main go routine exits, it will just only print the hello world. So I'll comment the line number 16. Let's see what happens. This is a similar program. Yeah, it just printed the hello world. So the child go routine did not get a chance to execute themselves. So I have used the time.sleep here. It's clear until then? Yeah.
So during the first iteration itself, all the 10 already created. Is that what the time is?
No, in 10 iterations.
Then if you are going to going through 10 iterations, then why will the execution of the whole thing be rapid? If we're going sequentially,
But
0
it's
to 9.
the go routine is just spawned. It's just told the processor that you have to execute this. It has not executed till it. Actual value is not calculated and it's not printed it, right? So that control is far more behind than print hello world control. So main controller exit itself, it didn't get time to execute that go routines. Is this clear? So when a new go routine is started, the go routine calls returns immediately. Unlike function, the control does not wait for a go routine to finish executing. If I have not used the go keyword here, so if I didn't use the go routine, the for loop has to be executed 10 times, right? So the controller will wait till the function returns. So this is not the case in go routines. Whenever go routine is called, it returns immediately. So yeah.
Instead of saying time.sleep, is there not any function which specifies that wait for these go routines to execute and then?
Yes, we are going linearly. So we'll go to that part and in the next slides. We do have that functions. So the main go routine should wait for any other go routines to run. If the main go routine terminates, then the program will be terminated and no other go routines will be the run. As we have seen in the previous example, the statements clearly states that. So, but this is a very small code, right? I have mentioned abruptly that wait for 2 seconds for other go routines to complete. But when we write a production level code, does we know what times the process will take? So is it a right way to mention that my program will sleep for 2 seconds? No. Yeah. So to solve these problems, we have a concept of wait groups in Golang. So what wait group does is it waits for multiple go routines to finish, and we can use a go routine. So wherever these go routines wait groups are called, so this waits for its child go routines to finish first, and then it's exits the control. So there is a standard Golang package called as sync, which provides the functionality of wait group, and it is used to wait the program to finish all go routines launched from the main function. So how to understand what a wait group is like? So let's consider we have one container and we have one counter, right? So this wait group is a type struct type, which provides three methods. These methods are add, done, and wait. What add does is whenever go is spawns, we have to add one, increment that container by one, that counter by one. Whenever a go routine finishes its execution, we have to decrement that counter by one. And what wait does is waits until this counter becomes zero. So
semaphore which is in COP. Like
yeah. Okay, so it uses a counter that specifies the number of go routine, and wait blocks the execution of the program until the wait group counter is zero. So let's see it by example. First, I'll use without wait group. I'll show one function without wait group. So this is a simple main function which has a for loop. I'm calling a go spawning 10 go routines and printing the hello world. As previously mentioned, I have executed this previously also. It will just print hello world. It will not wait for all the child go routines to execute. So to solve this problem, we have a concept called wait groups. This wait group is provided by a package sync. I have just declared a global variable wg of type sync.wait group. So in my main function, what I will do is first I have to increment the add. I have to add one to the counter. So whenever my go routine is spawned in a first for loop, my first go routine is spawned. Immediately after the go routine is spawned, I will add wg.add, and this parameter is the number of counter I want to increment, right? So I'll provide one here. So every time the new go routine is spawned, we will increment the counter by one. So when this go routine is executed, so this is the first line of a go routine. This prints the value I, and at line number 30, this is the part where go routines are ends, right? This is the last line of our go routine. So there I am doing wg.done. So what done does is it decrements that counter by one. So this is the internal in go routine. So what in main function, I want my main function to wait until the child go routines exit completes, right? So in main go routine, I have written wg.wait. Waits until the counter becomes zero. Whenever this counter becomes zero, it will control go. This unblocks the control, and this control goes to line number 36. It will print hello world, and our program will exit. So let's run this. So this is an execution, and at last we are printing hello world. So is this clear to anyone? What is the use case of it?
I have one doubt. Like, what if we got exception or error before that wg dot done, and the container will be not be at zero, so the main function will not get exit. It will wait for all the go routine to be get zero, and it will be not getting zero due to that error.
But error from where?
Like,
Go routine.
yeah.
So actually, if you see here, we don't have a way to return anything from it, correct? Because the go routine has been spawned, the actual function has returned. The go routine is running in its separate, let's say, a thread. Correct? So it can't directly return errors. Uh, as we discussed, that there are channels to communicate between go routines. So that is the way how we return errors. But since we have not used any channels over here, there is no way to return any error. If a error is coming in that particular go routine, it will just error out itself, but not return any error to the main thread, because there isn't any way to communicate between the main go routine and the spawned child go routine over here. So in that case, we won't have any error over here. But if you want to listen, we will see how we can do it through channels. And in this case, in this example, if you see, we have used wait group dot done. And now if you remember defer, like what defer does. So what defer does is it runs after the function execution has written, correct? So one example of defer is we can mention wg dot done in defer, because what we want is whenever our go routine finishes its execution, we want to call defer. So since this was a small function, we can write it itself. But let's say if your go routine is big, performs many tasks, you can just write defer at the start and mention wg dot done so that it automatically executes when the function returns. Because if any errors also come in your case, अगर बीच में कुछ error आ गया, but if you have written wg dot done at end, so it will not get caught. But if you have written it in defer, doesn't matter if error or not, it will still call the wg dot done.
So now we have learned that there is a concept of concurrency in Golang. We achieve this concurrency using Go routines. Now Go routines are run concurrently, right? But if you want to communicate between these two Go routines, so we communicate it using the channels. So channels are a means through which different Go routines communicate. So the syntax to declare channel is this is the actually shorthand declaration we are using. We are using a make keyword from a Golang to declare a channel. So what make keywords accept is it accept the type of channel. So I have declared a channel C here with the help of make keyword. This is a syntax chan int. This channel is of type integer. When we declare a channel of type integer, it can accept the value of only that data type. It cannot accept a string or float or any other value, right? So we have to declare a type of channel at the time of declaration. So now we have declared a channel. There are two ways we can send data to a channel, or we can receive data through a channel. Whenever we want to send data to a channel, we are using this type of syntax like channel, arrow, and v. So I want to write v to the channel. So to keep it simple, the data flows in the direction of arrow. Wherever the arrow is pointed to, the data flow in the direction. And whenever I want to receive the channel from ch and assign it to a particular variable, what I will do is I'll declare one variable and I'll flow that data from channel to that variable, so that that data will be assigned to that variable. Okay. So let's see one small example of channel. Okay. So I have I'm declaring one channel which is named as done, and its type is boolean. In the previous syntax, we have seen the channel of data type int. So this is the channel of data type bool. So at line number 13, I am spawning one Go routine and passing that channel to that Go routine, to that function. It is called as Go routine. So what does this function does is it accepts one channel of type bool. It prints hello world Go routine, and it writes true to this channel. Okay. So and at line number 14, I am reading from that channel. At line number 15, and I again printing it's a main function. So I'll execute this program. So at line number this first it prints hello world Go routine, and then it prints a main function. So is this clear?
Can you explain that line number 14?
Okay. So in channel, what happens is whenever channels are always a blocking call. Whenever we write in a channel, the right operation is blocked until someone other Go routine or some other process tries to read from that channel. Okay. So if I don't write this line number 14, this would be a blocking call, and the process the execution would have been blocked there itself. But at line number 14, I am reading the channel data from that channel, and my channel is now my channel is now unblocked. So at line number 14, I have not assigned any variable to this data, right? But this is perfectly legal in Golang. I may or may not assign any variable to that data that I have read. Okay. If I have assigned any variable, it could have read that true boolean and assigned to that variable. Okay. So that's the case.
This is another way we can wait for Go routines to complete. As we saw, wait groups. Wait groups are preferred, but this is another way. If you see the 14th line, it is a blocking one. So, so basically, there are two types of channels which you will see. So, since this is kind of an unbuffered channel, so it means it needs to, it can only hold one variable at a time, basically, a single value we can say. So it logs on the 14th line until it receives something. So since we spawn the go routine and on the 9th line, once it receives true, the 14th line outputs the value and then the execution moves forward.
As rightly mentioned by Prasad, we will see similar example of a blocking call. How does it work as a weight group? So the example we have seen here is an unbuffered channel, right? We do not, and it is always passed with a reference. So we have only mentioned a type of a channel here. We didn't mention the capacity of channel. Actually,
One arrow true means like the channel is ready to be unblocked.
no, we are writing a Boolean value true in that channel.
Okay.
That
Variable
means-
को value assign कर रहे हैं.
So this was an example of unbuffered channel. What does this make keyword accept is make accepts two arguments. One is the type of the channel and second one is the capacity of the channel. I haven't provided the second argument here, but what make if I haven't provided the second argument, so it accepts it as a zero value. Like it accepts it as zero. So my capacity of channel here is zero. So it's an unbuffered channel. So value is not written into a channel until someone tries to read it. And similarly, value is not read from a channel until someone tries to write it. So this is what we mean by a blocking calls. Channels are a blocking calls. So in both cases, it goes in a waiting state. So if a function or a go routine tries to read or write, it goes in a runnable state and then running state. So in Golang, the state management is done by go routines. If you want to transfer state, we can transfer it with the help of go routine. So as we have seen unbuffered channels, let's see how to declare a buffered channels and what is the use case of the buffered channels. So in buffered channels, the second argument in main function can be provided to initialize the buffer channel. So this is the syntax to declare a buffer channel, which accepts the type of the channel and the buffer value. So in case of buffer channels, it does not go into waiting state until the channel is full. So in the unbuffered channel, we have seen that we are writing a Boolean value in the, whenever we were writing a Boolean value into a channel, it got blocked immediately because it does not have buffer to hold the other variable. So we cannot write again into that channel until and unless someone tries to read from that channel. So what we have created is we have created a buffer of 5 in this channel. And similarly, if you take the previous example, now I can write 5 Boolean values into this channel until someone tries to read it. So if no one also reads it, I can write a value to that channel 5 times, and this is a non-blocking call. But after 5, the channel becomes full. If I try to write the 6th value, then it becomes a blocking call. So let's see one example of this unbuffered channel. In main function, I have declared a channel. This channel is of type string, and I have given a capacity of 2. So I have written Naveen to channel. Again, I have written Paul to the channel, right? So when I read 2 things to the channel, I just read in from .println ln. I read from that channel first time. Then again, I read from that channel. Okay, second time. So this is a very basic example of channel. Now I'll execute this. This will just print Naveen and Paul. Okay, but what happens if I try to write third value in that channel? Okay, right.
Do you understand why it is getting blocked? So like think of it in a way कि जैसे unbuffered channel भी था. तो basically ऐसा सोचो कि simultaneously the channel needs to perform both the operations, read or write. तो जैसे unbuffered के case में we will see an example क्योंकि वहाँ पे go routine था which was writing to the same channel and the main go routine was listening the value of the channel. But अगर हमने दोनों एक साथ लिखा, so in this case we write Naveen arrow channel, basically writing the value of Naveen to that channel, and in the next line if we are listening, and if this is an unbuffered channel, उसको हमने buffer नहीं दिया, it's just make chan string. and I'm writing both the lines below one another. ch Naveen and then print ch. तो क्या होगा कि I'm trying to write a value to the channel on the ninth line, but simultaneously दूसरा कोई गो रूटीन या दूसरा कोई फंक्शन मेरे चैनल के वैल्यू को रिसीव नहीं कर रहा बिकॉज वी हैवंट येट हिट द प्रिंट डॉट एलएन लाइन. तो वो उधर ही काइंड ऑफ डेडलॉक हो जाएगा क्योंकि चैनल्स को कैसे चाहिए अगर इट नीड्स अ वे वी कैन ट्राई इट आउट वो वन बफर करके वी कैन जस्ट कमेंट 10th 11th लाइन uh 13 feet. In this case, if we try to run this, so ideally, if you think here this is a variable, तो channel में चला जाएगा और next slide पे print करेगा. But if you run this, you will see we will get an error. ये क्यों होता है? Because ये deadlock में गया. क्यों? चैनल का साइज ऐसा सोचो 0 है. मतलब ऐसा सोचो वो जो पाइप है, अगर वो वैल्यू अंदर गया तो इट नीड समवन टू लिसन टू दैट वैल्यू. बट अगर वो साइमल्टेनियसली नहीं हो रहा है तो वो उधर ही रुकेगा. तो इसलिए इफ यू थिंक अबाउट इट, अनबफर्ड चैनल अगर होगा ना तो वी नीड एटलीस्ट वन गो रूटीन जो इधर लिसन कर रहा है चैनल का वैल्यू या तो राइट कर रहा है उसमें, क्योंकि इफ यू सी दोनों साइमल्टेनियसली चल रहे हैं राइट. तो एक कॉन्टेक्स्ट स्विच करके दूसरे गो रूटीन में जाएगा. अब इधर द सेकंड गो रूटीन राइट या रीड कुछ तो कर सकता है. तो ये साइमल्टेनियस प्रोसेस हो सकता है. बट अगर एक ही गो रूटीन में मतलब एक ही फंक्शन में अगर दोनों चीज लिख रहे तो 9th कॉल ब्लॉकिंग पे चला गया. अब कोई लिसन हो जाएगा ही 12th पे, क्योंकि उसके लिए क्या है कि कोई तो सुनना चाहिए साइमल्टेनियसली. तो अगर इफ आई जस्ट राइट द 12th लाइन इन अ गो रूटीन तो क्या होगा, 9th कॉल ब्लॉकिंग में चला भी गया. अब कॉन्टेक्स्ट स्विच होके दूसरा गो रूटीन रन होगा, उधर प्रिंट एलएन मेरा एग्जीक्यूट हो सकता है और फिर वो चैनल में से वैल्यू रीड कर लेगा एंड देन विल अनब्लॉक. बट बस बफर के केस में फर्क क्या बढ़ जाता है, क्योंकि मैंने समझो 2 का बफर दे दिया. अब 2 उसके बाद 2 का कैपेसिटी है तो मैंने एक वैल्यू डाला चलेगा उसको, ठीक है, और एक जगह है. तो फिर मैं सेकंड वैल्यू डालूंगा. अब इट इज फुल. अब इट नीड्स समवन टू लिसन टू दिस वैल्यू, नहीं तो क्योंकि उसको और आगे वैल्यूज नहीं ले सकता हो तो फिर से वो ब्लॉकिंग हो जाएगा. समझ रहे चैनल्स का कंसेप्ट है.
So we also have after channels we have a select case in Golang. So in Golang, select statement is similar to the switch cases. Okay.
channel thing. तो बफर चैनल का दिखा है कि रीड टू कैपेसिटी लिस्ट. तो अगर हमने इनपुट्स दिए तो उसको रीड करना कंपलसरी है.
टू के बाद वो ब्लॉकिंग कॉल हो जाएगा, वहाँ पे ब्लॉक हो जाएगा. आपको रीड करना पड़ेगा ना अनदर गो रूटीन में, तो ये अनब्लॉक हो जाएगा. वहाँ पे एग्जीक्यूशन वहाँ पे होल्ड हो जाएगा
जब तक उसका कैपेसिटी फुल्ली होगा. अगर तो 5 का साइज था, आपने 2 वेरिएबल डाला है तो कुछ प्रॉब्लम नहीं, क्योंकि अभी तक 3 का लिमिट बचा है उसके पास, तो वो ब्लॉक नहीं करेगा.
सर अगर जो मैंने 2 डाले एंड देन उसको रीड भी किया
तो ब्लॉक हुआ, फुल हुआ ना तुम्हारा चैनल वहाँ पे.
मतलब 2 का ही अगर साइज है और 2
अगर 5 का साथ मैंने 2 डाले
चलेगा
और उसको रीड नहीं किया तो फिर कुछ ब्लॉकिंग नहीं होगी.
नहीं, क्योंकि और उसके पास 3 का जगह बचा है ना, 2 एक्सेप्ट वैल्यूज, तब तक ब्लॉक नहीं होगा.
और अगर ये फंक्शन में बिल्कुल रीड ही नहीं किया तो फिर
कुछ नहीं.
Now the select statement, select case. So in Golang, the select case is similar, just like the switch case in other languages. But in select statement, the case statement refers to the communication, either send or receive operation from a channel. So what we do in Golang is, in select statement, we try to which channel has completed its operation, and we check whether we are receiving or sending a data to that channel. So that particular case is selected for which a communication is ready to happen. And if there is no case, the default case is used to protect select statement from blocking in condition where no communication is ready to happen. So we have 3 cases. We can have multiple cases. Whenever a channel is ready for a communication, we switch to that case. And if not, this can be a blocking call, right? If no channel is ready for a communication, this can block our execution. So for that, we have a default statement. If there is a no channel to communicate, we can execute the default statement. So let's see this by example. So I am declaring 2 channels of type string here, output 1 and output 2. What I am calling is, I am calling the 2 functions in a go routine, server 1, and passing the output 1 to that and similarly I'm calling server 2 and passing output to channel to that go routine. So in the select statement, what I'm doing is for the case one, I'm uh, checking if I'm getting output from if I'm receiving the data from output one, and if I'm receiving that data, I'm simply printing that data. And in case two, I'm checking if I'm getting the data from output two. So these go routines are spawned concurrently. So what the server one go routine does is it sleeps for 6 seconds, and after 6 seconds, it's write server one to the channel. And what server two does is it only sleeps for 3 seconds and it writes from server two to the channel. So what we are doing is we are explicitly making this for our understanding. We are making explicitly this go routine to sleep. So the server 2 in 3 seconds only it will write data to that channel, and this data will be cached by in select statement that we have got data in output 2, and this will just print the s2. So when I execute this, so I have got the data from server 2. So is everything clear? And if I use the default statement here, the both go routines will one go routine one will sleep for 6 seconds, the second will sleep for 3 seconds, but we haven't received any data, right? So the default will be executed in that case immediately. So if you want to say default, so default is executed. Now this is the use case of channels and go routines. But when we say that we are executing multiple go routines concurrently, there might be some critical section, right, in code. So does anyone know what does the critical section means? Yeah, right. So critical section is a shared part of our code which can be accessible by multiple go routines. And this suppose there are two go routines. And I have one value x, which is a critical resource, which can be accessed by multiple go routines. And these go routines are trying to increment that value and print that value. But whenever two go routines try to increment that value, there might be a case where that we can get the different results, depends upon its execution. So this should not happen in our code, right? So this is a critical section and we have to protect these shared resources. So in Golang, we have a mechanism of sync and mutex, which provides the locking mechanism. So critical sections are part of code that modify the shared resources. While running multiple go routines concurrently, these critical sections should not be executed simultaneously, right? So let's take one example. We have one shared resources x in our main function. So what go routine one does is it so the current value of x is 0, so it computes the value x plus 1 of that x. It's the processor halted the execution of go routine 1. It goes switches context to the go routine 2. What go routine 2 does is it reads the value of x, which is still 0, so it will also compute the x plus 1. Then again context is switched to the go routine 1. What this go routine 1 will do, this will now go routine 1 will assign the computed value to x. Now this x is equal to x plus 1. Now the value of x will become 2. So go routine 1 will return 2. In the same this one again switches context to go routine 2. Now go routine 2 also does the similar operation and value of x is now 2. So both these go routines will return value of x is equal to 2. This is the scenario 1. Then there is also one scenario. Go routine 1 and go routine 2. What go routine 1 does is the current value in the first step, current value of x is 0. In the second step, it computes x plus 1 value. And in the third step, before switching the context, it calculates, assign the computed value to the x, and now x now equal to 1. So from 0, x now become 1. After this values assigned to the x, now the context is switched to the go routine 2. Now go routine 2 does the similar steps as go routine 1, but now for go routine 1, 2 to start, the value of x is already 1. It computes the x plus 1 value, and now value of x becomes 2. So this is called as race condition. In some scenarios we are getting value of x as 1, and in some scenarios we are getting value of x as 2. So this is the race condition, and we need to solve this race condition. To prevent this race condition to happen, we are using a locking mechanism called as sync and mutex in Golang. So using sync and mutex, the race condition can be avoided only if one coroutine is allowed to access to the critical section at time, that is x is equal to x plus 1, and this is done using the mutex. So whenever the multiple coroutines are spawned, we are locking the critical section. Only one coroutine is allowed to lock the section, and whenever it unlocks that section, another coroutine is allowed to access that section. So mutex is used to provide a locking mechanism to ensure that only one coroutine is running the critical section of code at any point in time to prevent the race condition from happening. So let's see the example of race condition in program. So I have one main function here. It's font visible. I am declaring one w of sync.wait group, one variable of type sync.wait group. I am having a for loop which will run for 1000 times, which will increment the value for in each iteration, which it will increment the value of I by 1. I'll add 1 to the wait group, and I'll call increment function as a go routine and pass the reference of a wait group, right? So at the end of the main function, I'll add a blocking call here, wait until the all go routines executes, and I'll just print the value of x, means what the value x contains, which should contains the addition of all the numbers. So what does increment function do? It just adds one, increments x by 1, and it calls wget that the go routine is completed. So can someone guess what this program will output? Yeah, right. So every time we run this program, this x is equal to x plus 1 is our critical section, right? So as this section is accessed by multiple coroutines, it will always return a value less than, not always return the correct value. It will always return the any random value less than 1000. So if I run it for a first time, it will return any value something between 900 to 1000. Okay. So again, I'll execute this. So it has written 997. If I again execute this, it will return 948. So every time we are getting a random value. So to avoid this, we are using a locking mechanism. So let's use a sync and mutex. This is a similar example with the help of locking mechanism. What I have done is I have declared two variables, one of type wait group, another one is of type sync.mutex. Similarly, as wait group is provided by the standard Golang package sync, it also provides the mutex functionality. So I am doing the code similar here, but whenever I am trying to access this critical section, one change I have done here is only one in the previous example I was just only passing the wait groups to the function, right? But here I am passing wait group along with the mutex. So and both we are passing by reference. So what this does is at the start of the critical section, I am locking that section with the help of m.lock. Mutex provides two types, lock and unlock. Lock locks the critical section, and unlock unlocks the critical section, as rightly mentioned by naming convention, right? So I lock this section, I increment the value of x, and I again unlock this section. So only one go routine can lock the function at the same time, and whenever the function that go routine unlocks that critical section, another go routine can acquire the lock on that function. So when I execute this, every time this will return 1000, because multiple coroutines will not have access at the same time. Only one coroutine will have access to the critical section. So final value of x is 1000. If I run it any times, this will result the same 1000. So you have seen here in the traditional, till the function I was calling till now, I was passing directly by a value, but here I was passing by reference, like address of wait group and address of mutex. So can someone tell why we are passing by reference and not value?
Because multiple coroutines are accessing that variable,
Hmm?
and there is a single variable. So when we pass by value, it can create copy of that variable. So we pass by reference.
By variable, Which variable are you trying to say?
Weight group and
Yeah, right. So if you pass by a value directly, each Go routine will have its copy of that variable, right? So main Go routine will not understand which variable means it will not understand which variable is trying to access. So we are passing by reference. We are using only one variable and just passing its reference. So yeah, that's very important when you are using sync and weight groups. Okay. So we have seen how to solve a race condition using a sync and mutex. As rightly mentioned by Prasad a few minutes ago, we can also solve the race condition with the help of channels. So as channels are also blocking calls, we can block the execution of a main go routine until the child go routine finishes its execution. So buffer channel of capacity 1 is used to make sure only one go routine can access the critical section at a time. And before critical section executes, value is written onto a channel. Now, unless the value from that channel is read or no other value can be written to it, hence it blocks all other go routines. You will understand better by example here. Okay, so we have one variable x, which is a critical resource here, and we are just this is a similar example, but instead of sync and mutex, I'm using channel. I have declared at line number 18. I have declared a channel of data type. Give me a second. Motherfucker. Yeah. So I'm just instead of sync and mutex, I'm just passing a channel here. So if you observe at line number 18, capacity of my channel is just once. Once I write any data to the channel, this will be a blocking call until the other go routine tries to read value from that channel. So I'm just calling adding weight groups, and similar fashion instead of sync and mutex, I'm passing channel here and I'm writing a boolean value true to that channel. So whenever I write a boolean value to that channel, it will block that channel. It has capacity 1, it cannot write more value to that channel, and it will execute x is equal to x plus 1. As the channel is a buffer, it can accept one buffer, right? One value. It will calculate x is equal to x plus 1. Even though it does not finish this go routine, if second go routine tries to access this, it cannot write true again to that channel. This is a blocking call. And at line number 30, I'm just reading the value from that channel. Now this call is now unblocked, and another go routine is free to acquire lock on this channel, right? Lock means to increment the value. So this is how we do with the help of channel also. Does anyone have any doubt in this?
So if you know binary semaphores, it is kind of the same concept. कि 0-1 टाइम एक टाइम पे एक एक्सेस कर सकते हो until and unless you use the same object sync.mutex वाला. If you use 2 copies, तो फिर वो अपना अपना अलग अलग locks बना देंगे. And do you know about types of locks? Types of locks, blocking mechanisms.
Like one of is semaphore and the other is mutex. Mutex is kind of lock, read write lock. Yeah, but I'm not remember.
Read lock, write lock, read write. We also have a concept of closing a channel that I have not covered. You guys can explore more about what does mean by closing a channel. If you close the channel, if you can write value to the channel, or if you can read value, you can explore more about that.
Also see about read mutex versus read write mutex. इन दोनों में क्या difference है? But I see if anyone knows the main difference क्या है read and read write mutex में.
हाँ मतलब मल्टीपल एक साथ रीड कर सकते हैं बट कोई भी राइट नहीं कर सकता एट द सेम टाइम ऐसा वही है ना वो रीड लॉक शेयर्ड लॉक और एक्सक्लूसिव लॉक वैसा ही कुछ तो है
इसके अंदर मल्टीपल कंडीशंस होती है ना कि अगर लाइक 2-3 कंडीशन होती है अगर कोई मल्टीपल गो रूटीन्स रीड कर सकते हैं बट कोई राइट नहीं कर सकता उसी टाइम अगर कोई राइट कर रहा है तो फिर कोई रीड नहीं कर सकता हाँ, multiple conditions एक टाइम पे रीड कर सकती है, but multiple go routines एक टाइम पे रीड और राइट दोनों नहीं कर सकते.
ये किसके केस
राइट लॉक
Like in the read
Right.
log.
आर लॉक वाला जो फंक्शन है ना, वो एक फंक्शनलिटी देता है. जो सिंपल लॉक है ना, वो सिर्फ वो रीड करे या राइट करे लॉक ही रहेगा, दूसरा कोई एक्सेस नहीं कर सकता. लेकिन आर लॉक के टाइम पे रीड कर सकता है. अगर एक रीड कर रहा है तो कोई रीड कर सकता है दूसरा, लेकिन राइट नहीं कर सकता आर लॉक वाले.
फिर रीड राइट वाले केस में जैसे आपने बोला कि लॉक के केस में दोनों
एक ही-
ऑपरेशन एक ही मतलब एक
एक ही
अगर
चीज
एक
तो
बार
कर
लॉक
सकता
हो
है.
गया तो कोई
हाँ.
ले ही नहीं सकता फॉर एनी ऑफ द ऑपरेशन. फिर रीड राइट के केस में क्या होगा? रीड राइट लॉक.
रीड राइट के केस में आई गेस अगर एक टाइम पे रीड कर रहा है, मतलब एक प्रोसेस रीड कर रहा है, तो दूसरा रीड कर सकता है बट राइट नहीं कर सकता.
पक्का.
हाँ, मतलब केस तो वैसा ही है.
और ये लिख के रखो और एक बार देखो. ये तो ये स्पेसिफिक इसके केस में भी देख लो. अगर म्यूटेक्स वाला जो पैकेज दिखा है ना, सिंक डॉट
हाँ.
म्यूटेक्स वाला, उसमें तुमको दो ऑब्जेक्ट्स मिलेंगे. आर डब्ल्यू म्यूटेक्स वाला एक मिलेगा और एक जो अभी आपने यूज किया हुआ है. दोनों का बस एक डिफरेंस चाहिए तो देख लेना. और उसमें ट्राई आउट भी करके एक बार देखना दोनों लॉग्स लगा के कि क्या हो रहा है, मल्टीपल टाइम्स रीड हो रहा है कि नहीं हो रहा है. अगर कोई राइट कर रहा है तो उस टाइम पे रीड करते हो रहा है.
Okay, यहाँ तक क्लियर है सबको? So till now we have completed the basic terminologies in Golang, syntactical, its use case in Golang. Now we have to shift to how to use this in our production level code, right? How to structure our Golang project. So the process will continue further. So, yeah.
So So now that we have gone through some of the main concepts of Golang, we'll have a look at what are the ways of declaring or constructing an actual production level code where we have a defined architecture. So just say for example, if you have used Node Express again, so generally we follow MVC architecture also. So similarly in Go we don't have a defined structure. You will if you go and explore, you will find multiple formats which suit, which actually depends key what are you trying to achieve over there. So on the basis of that there are multiple formats. So I'll show you one which we commonly used over here. uh, and then as you go and actually type your code, you'll realize key what suits your code better. So we'll look at the architecture and then we'll try to implement those through an example. So if you remember, you had an assignment for personal experience tracker. So I've taken the same example and we'll explore that. And if you have any doubts, we can go through it. And then finally, we have a topic for unit testing, unit and integration testing. So we'll focus on unit testing main. So it's kind of important. And I'll also share some examples for integration testing. But we'll see some code for unit testing in this session. So as you see, so this is a high level architecture of how we go about writing our Golang code. So mainly there are four layers: the domain, repository, service, and transport layer. So by domain layer, what we mean is, as we know, when we write some code, there are structs, error functions, and common errors or global errors, and structs which we want to reuse. If there is any function, let's say related to user, if you want to create a user, get the user details, we can use the a common struct between these functions. So a domain layer or a domain directory is where we declare all these common functions. So what we can do is we can just import this wherever we want, in whichever file or whichever package we want. So this is the first basic layer where we can declare all the common stuff. And then comes the repository layer. So by the name itself, the repository layer is the one where we declare our DB connections. So we can establish our database connection over there and then share this database object throughout wherever we need to call any database functions. So this also contains the main interface for database where we mention a function methods. So it can be, let's say we are talking about users, so we can have a user interface, and then the user interface has methods such as create user, edit user, delete or fetch user. And then in this layer itself, we implement those methods. And then comes the service layer. So the service layer is the one where we actually write the business logic. The business logic can be performing validation. So when we are creating any user, we have validations such as check the email format, check the password length and stuff like that. So all these are related to our service logic, our business logic, what we want to perform. So this is the main layer where we perform all this stuff. And this layer then calls the repository layer, or the we can say the database layer, which performs actual DB operations. And then below this comes the transport layer. The transport layer is the one where, if you know about handlers, right, or handlers or routing, whenever a request comes in, so this is the layer which confirms that, yeah, what is the path, what is the type of request, and where or which handler or method we want to redirect this to. So let us understand this by examples. So as we said, the domain layer, the lowest level of abstraction. So this is where we declare all the common structs and errors which we want to import in different packages. So I'll show you this an example. Just a sec. So if you see this under SRC, see, we have the domain layer, the repository, the service, and the transport layer. So inside domain, what we can do is we can declare a common struct. So in this case, it was expense, and then the interface for the repository layer and the interface for the service layer. So there are two ways. You can also declare this repository layer interface in the repository package, but this is one way to do this. So what happens is, if in any case you want to use a struct, let's say I declared this struct in the service layer and I want to use this in the repository layer. So what happens is, if you have heard of import cycle, so import cycle means is, if I am importing a package from repository layer to service layer, or the service directory, this directory, now I can't import any functions or any of the stuff from this service package to repository package. This forms an import cycle. Then to avoid this, what we do is we create a separate package. Let's in our case it is domain, and we declare those common methods or structs over there. So what we can do is we can simply import this domain package in both repository and service. And in this case, it doesn't form an import cycle there. So over here we have the interface for our repository layer. And if you go inside this package under repository, so we'll go step by step. So first the domain, where we declare all the common methods and functions. And then a top-down approach, we have the repository layer which talks to our database. So inside our repository layer, we have a struct. Now, what's the use of this struct? So if you know, we have declared an interface, but we need a type to actually implement those interface methods. So we declare a type called SQLite repository, and then this has a single field inside it, which is the DB. So this is to maintain the DB connection option. And then, as we said, the repository layer manages the connection between the database. So this function here establishes the connection with our SQLite database. So for this example purpose, I have used a file-based database. So the expenses.db which you see, this is a file-based database which writes to this file itself. Once we have established a connection, this is a simple migration. So usually we have migration files in the repository layer itself, which contains all the migrations we want to run. So migrations are basically creating a database schema and inserting any initial data if you want. So we just create an expenses table before actually executing any piece of code. And once this is established, we get the database object and store it in a field. Clear till here? And we return the address of the struct. This is because we want to use the same database object wherever possible. So because if we use a copy of it, it will have multiple database objects. And if you know about transactions, so when we use transactions, what we want the same object. Because if a transaction is going on, and if I use another DB object, it will not know that transaction is already in progress. So that's why we want, if you know about a singleton concept. So say a singleton means that use a single object throughout our service. So that is why we store the pointer to the database object and pass this wherever needed. So this is where we established a connection with the database. And then moving ahead, if you remember, we had this interface which had all these methods for the expense track. Now under the repository layer, what we do is we implement those methods using a SQLite repository receive. So all this actual database queries comes under the repository layer. And then once we are done with this, once we have declared and written all our repository layer functions, then comes our business logic or our service layer. So we create a service package, and under that, similar way, we declared all the interfaces needed for a service layer over here. So this is the interface for service layer, and then the necessary methods under that interface. So now if I go under the service layer, similar way, we'll create a type to implement those methods. And then from the service layer, if you remember, the business logic needs to call the database. But to call the database, since we have implemented interface methods, we need a type which had implemented those methods, right? That type itself can call those methods. So for that, we have a field for the repo layer. So the domain dot expense repository. So this means this is a dependency. So a dependency is basically the things which we need to execute a particular method or particular function. So one of the dependency for service layer is the repo layer. So we need an object of the repository layer to call all these methods. The add expense. So since it has a receiver of the type SQL repository object. So if you see here, the new expense service. So in the main function, what we do is we first of all initialize the repository layer because it is needed for our service layer. So once we initialize this repository layer, we receive an object of domain.expense repository, which is needed by our service layer. So then we initialize an object of a service layer and pass this as a dependency to a service layer. So if we again go over here, we can see we receive this dependency and assign it to a repo layer object. Now, in a similar fashion, we implement all the necessary methods which we declared for a service layer interface. And this then internally calls the repository layer. So we can add any business logic we want. So in this case, for example, for add expense, we don't want any negative numbers. So we check all this service layer logic over here. And then once this is clear, we can go and call the repository layer. So any doubts until here? Yeah. So now since we have the business logic, we need a way to call the service layer functions. So that is done from the handler layer, which comes under the transport. So if you see here, the repository. So as we mentioned, the service layer is the middleman between the transport and the repository layer. So it has all the business level logics. Then comes the transport layer, which is being exposed, let's say, to the outside world. So the transport layer contains the router implementation. The router is the one which handles which path points to which handler level functions. So all those things and the main server initialization. So on which port, which address we listen to on incoming requests. So all this comes under the transport layer. So let's see it through example. Now this is the handler. So the handler is the one which takes the incoming request and then calls the our service layer or our business level logical functions. So we declare a struct or a type called as expense handler. And then in a similar fashion, since we need to call the service layer function, we need an object of the service layer package to call those methods. So we create a field for the service layer, domain.expense service. In a similar way, we initialize this in our main function. We initialize the service, then we pass this service to our handler method. And then our handler then implements the similar methods we need for add, edit. So basically all the CRUD operations. So in the handler layer, what we have is, so this is a common, what we could say, way to declare a handler, which accepts the HTTP response writer and the request, the actual HTTP request. So just let me show you. How do you- So in the main function, we initialize a repository layer, there are service layer, and there are handler layer. Now this is done, but we need a way still to route this request to that particular handler. So what we do, we have multiple packages actually in Go. So one of the common packages is NetHTTP and MUX. So we can, so NetHTTP is what we can say a standard package, and then we have MUX, and then there are multiple other. So Gin is basically a framework kind of, such as we have Express. So we have Gin. There are multiple other things, Google Kit and stuff, but we'll start off with MUX. So MUX is a package which we imported over here, Gorilla MUX, and then we create a router. By name itself, a router is a function which matches the pattern to a particular handler. So we create an object of the router, and then it provides multiple functions. So I've just used one of them. So strict slash is basically it looks for paths based on slash the path name, and then use. So do you know about middlewares? What are middleware? Uh, how do you use middleware?
These are the functions which get executed before after handler, like
between the two main functions, we can say.
So before or after or both?
Like we mostly use them for authentication and authorization and stuff, or if we want to change any response or request object for that, mostly use them.
So basically, yeah, correct. So middlewares are function which we can use before actually directing to our handler functions,
Mm.
or after a handler function completes, before we actually send the response to the client back. So before or after anyways. So in this case, if we want to use any middleware, we can use this use function and declare or just pass our middleware function over here. So actually I have wrote this middleware function here. So login middleware. So it is a simple one. What it does is it just logs the entry time and the exit time of our request and the path, the actual request URI, what the request was. Coming back, then we go to register our routes. So handle func. So handle func is a function which requires two things. One is the path or the pattern. So basically, what is the path? So the base can be, let's say, localhost 8080, our domain, and then the actual paths, the slash expenses which we are using to post or create an expense. So this defines that this is the pattern we are looking for. If this uh, is the incoming pattern, we redirect it to the add expense method. And similarly, if you see these are both common, but then the methods differ. If it is a put request on this path, we redirect it to the edit expense method. And then if it is a delete request on the similar path, we redirect to the delete expense method. Okay. And there is also one case, let's say if we have slash expenses slash ABC, for example. So what happens is, let's say this is a path. So in this case, we don't have this declared over here. So what our routing functions does is it basically searches for the string which the maximum, what we can say, the largest string which is common. So it will start from slash expenses slash ABC. It will see if it has any path matching to this. If it does, it will simply redirect. But if it does not, it will now remove the ABC part and then look for slash expenses. So whenever it finds slash expenses, in our case, our first route, then it will redirect over there. So just a thing to remember. So it does not depend on the sequence of how we have written the paths. It just looks for the longest matching string when it tries to match the pattern of where to route. And then comes the initialization of the server. So we have used a net HTTP package over here, and we have a function listen and serve. So what listen and serve does is it accepts the address, and the address is in the form of domain colon port. So domain being whatever your domain is, but in our case, since it's localhost, if you don't declare it, it by default takes our localhost address and then colon the port. The port is where we want to listen for a request, and this is a TCP connection. So it listens on our TCP port 8080 since we have declared here, and any other port we want. And the second function is the handler. So by handler, what we mean is, let me show you. So a handler is basically an interface which has the method serve HTTP, which has two arguments, the response writer and the request objects. So basically any type which implements the serve HTTP method can be considered as a handler. And the second thing, if you remember, an interface can be nil. So in this case, it is not compulsory to pass this second object. We can also have this as nil. But in this case, what happens is if we pass this second object as nil, what it does is it uses a default router. So in case of default router, what we have is default router tries to, so in this case we'll not have mux then, because we have explicitly used a mux thing. But in case of default router, we can use the net HTTP function, HTTP dot handle func, and the same way. So it will use this default router if you have mentioned all these fields, and then route to the methods which we have mentioned. And if not, then it simply returns a 404, not found error. Uh, Clear till here or any? So this is basically two ways: using the net HTTP package and using external package such as Gorilla Mux to declare our routers. So if we are using the net HTTP one, we can simply have the second argument as nil, and then it uses the default routing methods.
I have one doubt, like how do we use middleware in this? Like in Node.js, like we directly pass the wrapper function of that function inside that handler.
So yeah, two ways. One is, since we used mux and we wrote our let use, right? So what it does is, this is kind of middleware chaining. So whether for each function which we have declared using this object R, so all these routes are declared using this object. So before any of these handlers are hit, this logging middleware will run. But if you want specific, there are again two ways. So you can declare it on a particular prefix, that if we have this prefix, then only change this middleware. And the other is, as you said, we can also wrap for each function. So basically, if you see, this is a method which you're calling, but before calling this, we can wrap it. So but we need to modify this function in such a way that this accepts a handler, but instead of that, it will accept that type of function which we have declared over here.
Does we need to call it with next method to that?
In this,
Yeah.
in this scenario where we have passed the handler, then we need to call the next method, which redirects to our handler. So let's say if we had x slash expenses slash handle dot add expense. So what happens is, before we hit this, it goes to this. So in this case, we need to call this next method and then pass the response writer and the request object to it. Actually, this is one of the common ways. We can also wrap it, but it's, if you see, wrapping doesn't seem efficient. So what we can do, if you want that particular parts to have a middleware and other parts we don't want, in case of, let's say, authorization. In case of authorization, our public APIs don't want that. So we can declare that this particular path should have this, call this middleware, and some don't. In that fashion, it's easy to implement. Let's try to execute this. So we have our server running on 8080, and just this is a get request to our expense path, and actually it accepts two parameters in our case, which is the from and to. So I want to fetch expenses from this date to this date. See, what we have here is 404 not found. Let's check what is the issue there. So we have Nicholas 88. So it should hit this method, correct? Which we have slash expenses get dot get. Now do you see why it is not calling it? So if you remember, I told you that if you pass nil over here, it uses the default router, but we haven't defined these methods for the default router, and in that case I told you it returns not found. So in this case it is returning 404 not found. So since we are using mux, what we need to do here, we need to pass our output. Let's rerun this. Started this. So I will get the request back. So initially I had an object. So the flow goes in such a way. So first we hit our router layer, then it looks for which pattern is matching according to the request. So once it sees that we have the slash expenses method and it is a get request, it then routes to the handler layer. And inside the handler layer, we have the response writer and the request object. So we need two things from it, the from and the two query params. So this is one way to read those. So query.get methods, and then some basic level validations, because since this were the required fields, we perform the validation here itself. If any of this is missing, we can just write a response error into the response writer object itself. So there are two things. One is the actual error message, and then the second one is the status code, and then return. So once this is done, we call the next step, which is the business logic or a service level methods. Service layer method, any business logic validations we need over here, we can perform, and then we simply call the domain layer or the database layer. Now this is a pretty simple code, but in majority of cases, what we do is we try to listen to the error which we got from here, and basis on that we can decide what exactly to return. So let's say there can be cases if some of the fields are unique. In our case, let's say name is unique for our expense struct. So the database can return a conflict error. And in that case, we want to send some user defined or a user specific message. So what we can do is, in this case, instead of simply returning the error, we can listen to that error and then check if it is a specific error. Let's say I'm just writing over here. If let's say the error was specific, key DB constraint or something. And in case if you use Postgres or SQL, they have specific error codes. So you can listen to those error codes instead of typing a string literal over here, and then decide what specific error you want to return. And then, for example, let's say you can have errors not new. One way to create a new error, and then so we want our errors to be as user friendly as possible. So this is one type, and then if it's something other than this, then we can just return a common error. Let's say something went wrong, or please contact, such kind of things. So this is also done on the service layer, handling of errors basically. And just remember, it is important to handle each and every error. If we skip any error, it might lead to a panic, because in normal cases, what happens is we are returning, let's say, two objects. Say in a get expenses by date range function, we return an error and a struct. So normally what we do is, when any error occurs, the first object can be nil and then an error object. But if we fail to handle the error, we'll just try to access that object, and since it's nil, so in case of nil, if you remember, in case of nil, if you try to access a nil object, it panics. So it is preferred that if any function returns error, we need to first handle that error and then go on to access any struct or object it has. So any doubts still here? So this is one way we declare or create a repository. And for now, you can follow the same method when you do your actual assignments. So we have the server inside which we declare our main function. And the main function does the initialization of things. So the repo layer, we go in a hierarchical fashion because a handler needs the dependency of a service object. A service needs the dependency of a repo layer object. So we go in that fashion. We first declare the repo, then pass that repo layer object to a service, and then service to a handler. And then there are scenarios. For example, let's say inside our repo layer function, when we initialize the DB. So in this case, we have a DB path. So when we initialize, let's say any Postgres or SQL DB also, we have a connection string, right? And a DB password. So normally what we do is we read this from environment variables, basically secrets. So to start a service, it is, let's say it is compulsory to make the DB connection. But let's say due to some human error or due to some issues, we forgot to add the DB password or the DB connection is not made. So sometimes it wouldn't make sense to start the service without the DB connection. So these are some specific situations where we, uh, raise panic in the code itself. So what it does is, if we raise panic, either we recover, we log somewhere, or we don't let the service to start. So what it does is it let us know that some absolutely required field is missing, due to which we can't start the service. This is one scenario where we can have panics or raise panics. So these are, let's say, our service functions or any third party service which we need to actually run our code. So these are some places where you can explicitly raise panics if you want. So if there are any doubts, we can discuss, or then we can move to the test cases, unit test cases part.
What is that file dot QODO?
This
Under same
DO क्या है बोल रहा है?
वो VS Code का cursor का है actually, basically. So one other thing, if you are using cursor or any other ID, so let me show you. So basically we have a agents.md file which you can declare for your any code. Let it be front end or back end. So let me show you an example. So what it does is, before you run any cursor command, it will refer to that file over where you can mention any instructions you want for each prompt you run. Basically, it will refer to that file, and in context with that file, run your prompt. So the file declares so now this is with respect to our project. So what all things we want cursor to consider before it updates or suggests any piece of code. So it can be, let's say we have naming conventions. So we can declare those key whenever, let's say, cursor writes a piece of code, it will then follow those naming conventions. Or if you have, since we have packages, we have created packages like this is a service package, this is the repo layer package, this is the transport layer package. So we can mention our structure over here, and then have explicit commands or guardrails. If this is a kind of function, if it has anything related to database, we want it to go in this package. So all these things we can mention in this file, so that cursor has context whenever it tries to modify a code, that where to create this function or where to create these methods. So in a similar fashion, if you see, we have some what we can say some conditions. Whenever cursor makes any change, I want it to run all the test cases. So I can mention over here that for testing, please run this command whenever you make any change. So all this can come under the agents.md file, whatever conditions you want. So each time whenever you run any command, you don't have to mention this explicitly. It will just refer to this file and act accordingly. So once you get started, you can, of course, you can use ChatGPT to create this file. So, so this is a detailed one, but you can start from small. That these are my tree structure or my folder structure, and this package defines this. So cursor will implement those methods there itself. And then let's see things related to test cases. This is the router creation. So we generally have two types of tests: integration tests versus unit tests. So before I start, do you have idea what's the main difference between these two?
In integration test, we test two or more features which are working together. If they are properly working integrated together, whatever I'm passing to a next feature, is it handling it correctly or not? And in unit test, we test a particular feature or particular functions.
Any other definition or explanation here? So yeah, so you are correct. So in case of integration test, what we do is we try to test the entire flow of our program. And in this case, let's say if we have a database layer or third party calls, we actually let the test cases call those at the database and the third party calls. But in case of unit test, what we do is by name itself, unit test, what we want to do, we want to test the smallest piece of code which we have in a program. And in doing so, we don't actually call the actual database, or let's say if we have a third party integration or third party service, we don't call that service. What we do is we mock. So by mock, what I mean is we try to create, yeah, fake output. In we define that if this is the input, we want this as output. So so the main use case is this: unit tests are helpful because first of all, unit tests are fast because we don't actually are connecting to the actual database or calling a third party service. We are just simply creating mocks and returning results from them. So one our it is fast to run. So whenever we make, let's say, any changes to our code, and we just want to verify if our changes are breaking any previous implementations or not, what we can do is we can just simply run those unit tests, and we can confirm if our implementation is breaking previous code or not. So that is one of the advantages of writing unit tests. So it's and unit tests can be returned for functions or packages. But if you see in Go, what we do is we try to keep it related to a function, because functions are the basic units or the building blocks of our code, the smallest thing possible for us to test. So let's see an example for this expense service itself. So before I start this, uh, for unit test, as I mentioned, we need mocks. So if you remember, we studied about interface, and what interface does is it declares all the methods needed for a particular, let's say, operations. So one of the usefulness of interface is when we create mocks. So what mocks does is it looks at an interface. So there are multiple packages to create or multiple libraries to create mocks. So in our case, we have used Go mock. So what it does, let's say I have mentioned it that you have to look at the expense service interface and create mocks for all these methods. So, and we declare the package or directory where we want our mocks to be generated. So if you see here, it implements all those methods, the add, delete, edit. And So this is auto-generated code. So we don't need to look at this, but just refer this. So what happens? If you remember, in case of interface, what we can do, any type that implements those methods, we can use that type wherever we want. We don't need to actually replace the internal implementation, right? So for example, in case of a service, uh, let's go to our handler. We are calling this get explains by date range, correct? And what it defines is we need a service layer object to call this method. But in now we are trying to write test cases and we want mocks, so we don't want to call the actual service, because the actual service then internally calls the database, but don't want that. So once we create mocks, so what happens is the mock also is implementing this same interface methods. So what we just need to do is we just need, when we initialize a service object, so which is this function, we pass the service dependency. But now in test cases, what we can do, we can simply pass the object of a mock. So if you see over here, see, we create a mock object and then we pass this to our new expense service function, which is this. This is for the service layer test case. So it accepts a repo layer or a DB repository layer object, but we don't pass the actual object, because if we pass the actual object, it will call the actual database layer function. So we simply create a new object which implements that interface. So our service can still accept that object because it has the same method implementations. So when we replace this with the mock object, whenever it calls this add or edit functions, it is now calling the mock functions instead of the actual database layer functions. Okay. So is there any doubt over here? So because, and now consider if we didn't use interfaces, if we directly use struct level methods, or if we try to initialize, let's say, instead of having these dependencies, what we did is we internally created this dependency for, say, service equals to what we had, repo repository. If we did it this way, then it kind of becomes difficult to mock the service because it internally is creating the dependency. Now we can't pass any mock object to it. So that's why in any case, when we declare any struct or try to implement interface methods, all the dependencies we want, we accept it as function arguments. So it is helpful while writing test cases too. So we can just pass on mock object to that service before initialization. So while writing test cases, have you heard of test-driven approach? So there are so what is test-driven approach?
Write your test cases even before you start writing the code.
So that is one approach. So what we do is, since we know what our output is or what we want to achieve, what we can do is we can first start by writing test cases or scenarios for that operation. Let's say in our case, add expense. So why this is helpful? Because we know what we want from our service. So we declare those scenarios and then we can start writing our actual implementation or logic. So what happens is this is helpful because if it becomes kind of impossible to miss any cases. On the other hand, if we start by writing the logic and then the test cases, there might, so what happens is, I have observed, or if when you write test cases, you'll also see what we try to do is we try to satisfy that function by ye pass hona chahiye. So we don't actually look at scenarios then, ki what all things we need to check or what all validations we need to have. So if we start from writing the test scenarios first, just the scenarios, then at that time we think of such things, ki kya kya validations hone chahiye and stuff. So this is a recommended way. It sometimes might get, what we can say, hard in production level code, where let's say you have uh, a code itself and you are just now trying to add some feature over there. It might get difficult to do it in that scenario. But still, what we can do is you don't need to write all the test cases first. You can just mention scenarios you want before testing, before writing your actual code. Now, what you see over here is this is uh, one way to write test cases. So, just if you want to write it down, there is a testify package which also helps us to write test cases. And in our, what we can say, uh, most of in our office we use this testify packages also. It is quite helpful. I'll also share an example with you. But for this demo itself, I have used the normal testing package, the standard testing package which we have. So, like, so before writing any test case, what we do is we initialize all the mocks which we want. So since this is a test case for the service layer functions, so we needed the mock for our repository layer. So what we did is we created an object for our repo layer and then passed it as a dependency to a service layer function. And then this is a convention which we use. So basically, we declare a struct and all the things which we need for the test case. So one is the name. So the name can be the scenario of the test case. Let's say it's a success or failure scenario, or you want to test a specific, let's say a validation. So you can mention over there. So it's easier for you and other person to understand what this particular test case refers to. So we have the name, and since we are testing the add expense method, we'll see what all things that add expense method needs. So the add expense method accepts a struct of type expense. So we mentioned that over here, the expense struct which we need. And then we have this mock function. I'll let you know how we use this. And then the response. So in our case, the add expense returns an error type object. So we when we do this test case, we verify this if it returns any error or not, or if it returns any error, what type of error we were expecting, and is it returning that or not. So since we have a array over here, a slice over here, we can declare multiple test scenarios and then run it simultaneously in a for loop. So for the first scenario, we have a success scenario. Then we declare the actual object, the expense object, and things which we need. And then you see this mock function. So this is kind of an inline function which we are assigning to the mock variable. And what it does is, so now we want to actually mock the repo layer call. We actually don't want to call the repository layer. So the mock function, what it does is it lets us define what we want to return if we receive a particular kind of input. So, so this is the mock object which we created earlier. So it has some inbuilt functions. So these are the inbuilt functions which they have. Sorry. So what it defines is if we, so in this case, we have mentioned any, but we can specify that if we receive this particular type of object, domain dot expense, we want what we want to return. So in this case, our actual function returns an error, but since this is a success case, we want it to return nil. So we mention that return and what we want to return. So it accepts our interface, so it can be anything. It can be a specific object you want to return, and in our case, since it's an error, you want to return a nil error. So we have mentioned nil. So what happens is when we run our test case and it goes into the service layer, whenever it finds this particular function. So what we have defined is when we call this add function, and it, so we have defined it any over here, but we can also define that if it accepts if it gets a domain dot expense struct, then only return this. But since we have defined any, we can pass anything, and whenever it hits uh, this line of code, instead of calling the actual repo layer function, now it will execute that mock function and return error from there. Any doubt till here? And then in a similar fashion, we have a second test scenario where we are taking a failure case, so invalid amount. So if you remember, we had a validation to check that the amount can't go negative. So if the amount is negative, we expect the function to return an invalid amount error. So we check that over here, that if it is returning a correct error or not. And if you see, the mock function is empty. Why? Because we never expect it to hit this line of code. So that means it will never call the repo layer add function. So that's why we don't mention the function over here. But in case, if let's say you still write this line of code and you tell the mock that I am expecting a call to the add function. So if you run this test case, then you'll get an error saying that an expect we the mock expected an add call. So if you face this kind of error, you can just go and check the actual execution flow of your code. What happens is, if I go here and mention that we are expecting a repo layer add call, but in our actual code, if you see, it will hit this line of code, and since it's negative, it will return and it will never call the repo layer add function. So our test case actually fails because we are saying we expect a call to the add function, but it isn't getting called. So this is one of the case where you might see some errors. So let's try to run this without calling the mock function. So we have two scenarios, the success and the invalid amount one. So we get fail. This is happening because we told the mock that we are expecting a add call, but in reality we never got to that line of code, so the add call didn't happen. So it matters if you how you write your mock level calls. If it is needed, then only we mention it, and if there are multiple repo layer calls, so we mention that in that sequence. So let's say if in this function there was a call to add, then let's say there was a call to the get function also, the repo layer get function. So we write the mocks in that sequence. So first we are expecting the add call, then the get level. If we change the sequence, we write the mock for get first, then add, then also we'll face an error because it sees that first we are expecting a get call, but in the actual service, it calls the add functions. So that is one case where you might face errors. So it's important that we write a sequence properly when we write those mocks. And then we simply iterate through this test scenarios, then call the actual function which we want to test, and then pass this expense object which we declared over here to the actual function, and then perform the actual checks which we want. Since this function returns an error, we had a want error field to actually verify that what is the error we expected. And if it fails, we can just either log, and there are other functions too to verify all this stuff. So you can also see this. So this is one of the methods which we use. And then similarly, we have test cases for different functions. So I'll share this with you. So in your second assignment, basically it is expected that you declare like you create this repository. You have at least three packages for repository, service, and handler, and then of course the router layer where you define the paths. And once you have done this, it doesn't need to be in detail. Some basic level functions for creating, editing, fetching, and deleting your expense, and then at least two test cases per function. You can for this you can start with the service layer function, and if you want, you can write test cases for each of the layers. Let's say handler also. But for now, for this assignments, you can just write it for the service layer functions. So, any doubts or any questions regarding anything which we talked about today. So testing is the main thing. You'll have doubts regarding this. Feel free to ask, because once you start actually writing the test cases, that is when you will realize कि क्या issues आते हैं उसमें क्या नहीं. So, and there is one other thing which you will see while writing test cases. Now, let's say we mocked our user defined functions, but let's say there are cases where you are using packages and you want to mock their functions. For example, uh, let's say we have time package, time.now. Now, time.now is not your function. It is a library defined function. And in that case, how will you mock that? Because let's say your response object was having created at field, let's say, and you use time.now over there. Now, each time you run your piece of code, what it will do is it will run time.now and it will give the time at that instance. But while writing test case, you see in this scenario we had, let's check for get. So we had a want field which we used to compare the actual received value versus what we wanted. But in this case, what we normally do is we declare what all fields we want. But still, if I use time.now over there also, it is not mandatory that this time.now versus the actual service layer में जो time.now use किया है, ये दोनों एक ही instance पे run होंगे. कुछ ना कुछ time में difference आएगा ही. So it will always say कि not matching, that both the actual response which we wanted and the response which we got didn't match. So in this case, what we will do, तो वो एक ट्राई करना कि दिस इज एन एग्जांपल कि जहाँ पे तुम लोग ने खुद यूजर डिफाइंड फंक्शन नहीं है, तो उस केस में कैसे मॉक करोगे या उस केस में क्या कर सकते हो. सो ट्राई टू फाइंड आउट दोस. अगर नहीं मिलता है तो रीच आउट टू अस, वी कैन लेट यू नो. दिस इज वन ऑफ द एग्जांपल्स. एनीथिंग go to each channel is so actually I've used Go mock package over here. There are multiple packages. Mockery is one of them. So I've actually mentioned commands over here which you will need. So this is the one which, if you are using the Go mock package, this is the command which we use to actually generate those mocks. So mockgen is the keyword, then the source. The source is where our interfaces are defined. So this is where it will look for the interfaces to generate the mocks, and then the destination where we want the mocks to be generated. So in our case, it was the mocks package, this mocks, and mock repository.go. And then to run tests, we have the go test function, which basically runs all the test case in all our packages. And then hyphen cover helps to see the coverage. So coverage is basically how much part of code you're covering in your test cases. And then the third one, this is a detailed one. So what actually this does is it gives you a HTML file which you can just see in a browser, which then shows you color coded kind of thing. This all parts of lines are covered under the test cases. So for example, the green lines are the one which are covered in your test cases. Then there are red lines which are not being covered in your test cases. So a detailed view for that. And there was one more thing when we were talking about the sync and mutex, the race conditions and stuff. So there is also a command called go race, which we can run on our terminal. Which simply what it does is it's before running your code, you can just check if there are any cases or race conditions that might happen in your code. So this kind of helps to identify those cases. If it sees some logical deadlock happening in your code, it go race is the command which helps to identify. Not necessary ki each time it will help. depends कि एकदम basic है. Let's say you're trying to assign a value to a channel and then simultaneously उसके नीचे an unbuffered channel declare किया and you're trying to read it. तो लॉजिकल ही है कि वो डेडलॉक में जाएगा. So all these conditions can be identified using OS. So for today's assignments, basically the last assignment was declaring interfaces implementing a terminal level function. एक ही file में. But for the second one, what we expect is the same thing. The same functions can be there, but now you have to create the packages for repository layer, service, and handler, and then expose this through a server. Or so basically, we can call all these APIs through a Postman thing. And the first one can be a terminal based, the first assignment.
सबसे देखा ना पैकेजेस क्या होते हैं, गो मोड कैसे क्रिएट होती है, गो सब फाइल कैसे दिखती है, देखा ट्राई आउट कर बिल्ड करके देखा गोलैंग का.
So अभी हमने डायरेक्ट रन किया गो रन करके main dot go. So it actually just runs your code. The other one is go build. So go build executable file बनाता जैसे C++ में हम बनाते हैं same kind of thing. एक executable file तो फिर मैं वो आपको डायरेक्ट दे सकता हूँ and you can run it. So वो भी एक ट्राई करके देखना. And for database actual code में तुम ये भी यूज कर सकते हो एक फाइल बेस्ड डेटाबेस. इफ यू वांट आप जिससे भी कंफर्टेबल है पोस्टग्रेस एसक्यूएल आप वो भी यूज कर सकते हो. एंड एक रीडमी वगैरह भी मेंटेन रखना क्योंकि आप एआई यूज ही करने वाले हो तो थोड़ा सा अच्छा दिखने का. और ट्राई करो कि ऑफ यूज एआई सिंस दे आर encouraging बट लाइक अंडरस्टैंड व्हाट इट इज डूइंग. बिकॉज फिर इट वुडंट मेक सेंस कि आप अगर पूरा ही जो भी आप यूज कर रहे हो आप एक अच्छे से प्रॉम्प्ट दोगे वो पूरा कर दें बट फिर आपको एक्चुअली वो इश्यूज आने दें. तो ट्राई टू एक एटलीस्ट एक फंक्शन खुद से ट्राई करो. देन जो भी एरर्स आते इश्यूज आते हैं देन ट्राई टू रिजॉल्व इट विथ एआई. कुछ एरर्स वगैरह आते हैं